Okay, so I just want to welcome everybody. This is, as you know, one of many free webinars that we've been putting on this year. We started to do, and it's these webinars really are being put on by a collaborative group of organizations, the ELA, the Ecological Landscaping Association, as I mentioned, which I'm a part of, the Chesapeake Conservation Landscaping Council, the Midwest Ecological Landscape Alliance, MELA, and the Eco Landscape California organization. And we're doing this really because all of us are very involved in education, and we're trying to sort of expand that reach. And this is our third webinar, and so far they've been going pretty well. So we're happy that you guys have signed up. So the first thing, so to get started, I want to introduce our speaker tonight. Very excited to have him, just such an expert in his field. Chip Osborne, he's a professional horticulturalist for 40 years. And I think the important thing, what he wanted me to tell you, is that he was, self-employed in the nursery greenhouse arena in that industry, and he was a huge pesticide user. And he just was determined that there was a better way. And so now he's president of his own company, Osborne Organics. It's a natural turf consulting company. He goes all over the country to talk. He just told me about an intense schedule he has over the next few months. And so we are just so fortunate to have him. So I just want to welcome Chip. And
well, thank you very much, Reason. It's my pleasure and privilege to be here with you, today and talk about this subject that many people in the land care industry regard as sort of one of the hot topics. This idea that we can learn to manage landscapes, and particularly we're going to talk today about turfgrass. In a less chemically intensive way than many of us have been taught in the past. I would certainly like to acknowledge and thank the Ecological Landscape Association, Chesapeake Conservation Landscaping Council, Midwest Ecological Landscape Alliance, and Eco Landscape California for this collaboration and coming together to bring this series of, very important industry topics out there. There was one time when this, this idea of alternative management strategies was out there on the fringe, but I can assure you now that we are fully mainstream. We certainly don't command the market share of the industry that the conventional side does, but always growing and something that, is certainly here to stay. It's something that is always going to move forward. The intent of this hour or so that we're going to spend together is designed to give a broad overview of sustainable turf management practices, including basic principles and protocols involved, so that there will be hitting the high points and the things that we look at, that we consider, but certainly not intended to be the takeaway to teach you everything that you need to know about these practices. It's always been my opinion that the most limiting factor that stands in the way of a more widespread adoption of these practices is simply the lack of education in conveying the information on how this can be done, and a large focus about what I do, as Risa said, around the country, is raising awareness, but also bringing the education, the strategies that we employ to ensure that we can do this successfully. Many of you have probably heard that, natural lawn care or large-scale turf management, non-chemically is too expensive and doesn't work. No longer true. We have technology now that has emerged in the last year or two where we can be extremely competitive on cost, and there's certainly enough models out there to show that when done properly, it really works. The concepts that I'm going to put forward for your consideration are relevant for all aspects of the industry, including lawn care service providers, those companies that make those applications for fertility, maintenance companies, landscape architects involved in the design phase of the landscape, landscape design and build companies. We're going to spend a little bit of time talking about how in the design and build stage, getting things right up front, getting things done correctly, make management much easier in the past. It's very important as we begin this discussion to understand that we need to integrate the concepts of healthy, biologically active soils, the right grass plants, bringing that together into our designs from the beginning. How we approach it at that level determines the success in management later on down the road. Many landscapes are in the design and plan stage with the intention that a chemical management program from both nutrition and control will be the standard approach, because that is the standard approach currently in the industry. Synthetic chemicals for both fertility, nutrition, fertility, and for control have the distinct ability to override poor soils. They can make poor soils act in a way that nature may not want them to. The wrong choice of plant material can be in there, but for a short period of time, chemicals can override some of the negatives. Ultimately, we have problems developing in that scenario. When problems develop, then we choose a synthetic product, but that product is treating symptoms, and that really is the key point, that type of material treats symptoms, but it never really solves the problem. So what we're talking about here in alternative are problem-solving strategies. Paying close attention to all of this from the beginning makes things much easier after installation. So with that, that sort of overview of my approach and where we're going, let's jump right into it. So that's the subject that we have today. The bottom line is that homeowners, parents, citizens are beginning to ask about and request a non-toxic approach. So where, it doesn't really matter what, those of us, how we all feel about chemicals, pro or con. The fact is that the market is changing. There's a reason for these discussions, the reasons of protecting human health and the environment, those discussions that are permeating through certain aspects of society, municipalities, school districts beginning to request this approach. Bottom line, for those of us in the industry, this is a business opportunity. We have an opportunity here to capture some market share. My approach never has been to tell everybody to stop doing what they're currently doing and do it this way, but maybe adopting some of these strategies and then incorporating that into a business model and taking advantage of that particular opportunity. So what we're talking about is a systems-based approach to management. Systems-based approach is a concept that I came up with that incorporates different aspects of what it takes for this to become successful. The systems approach is the opposite of a product approach. In our conventional training, we are taught to use product for all aspects, for nutrition, for control. What we're doing now is looking at this as a whole, complete, healthy system. We need to understand how the system works and how to make it work for us. To give you a real world example, 10 years ago, a set of athletic fields was transitioned into non-chemical management. No chemicals have been used in the last 10 years. The system is fine. You're seeing a picture of it right there. The first soil test showed that that acre of topsoil there was generating about 85 pounds of nitrogen on natural processes. As of 2010, that same acre in front of you is now generating 150 to 175 pounds of nitrogen through natural processes. So that system is now working for us. And then what that has translated into is a substantial reduction in budget. This is the systems approach, a threefold concept. It applies to all aspects of the landscape, not just grass. A basic understanding of soil biology. We'll walk through some of the concepts here. And we don't all have to be soil scientists, but taking us all back to high school biology class, where at some point a teacher told us that a handful of soil contains billions of living organisms that nature put there for the sole purpose of facilitating the growth of some type of plant material. By far and away, the largest percentage of those organisms is entirely beneficial. There certainly are pathogens or bad guys, but the concept that we're operating from is that if we encourage and develop the health of that soil, good guys outnumber the bad guys, and the system begins to work for us. Second part of the systems approach is the use of product, natural organic product, based on soil testing. Critically important. That we're really not doing much of anything until we have a piece of paper in hand to tell us the direction in which we need to proceed. More often than not, a soil test saves us money rather than costing us money. And then the third aspect of this is revised horticultural practices. We all know of those cultural practices, things like mowing and irrigation, seeding, overseeding, aeration for the relief of compaction. But historically, those cultural practices have taken a back seat as the chemical management framework became more ingrained into our practices. I've talked with folks and extension agents around the country that readily admit that it became pretty easy back in the 60s, 70s, 80s to prescribe remedies from bags, boxes, and bottles, and so that was sort of the way it went. And now we're coming back completely and looking at this whole system. Certain things that we have to consider up front as we begin to talk about this and how we're going to make this successful, because our goal here is not to just stop using these products and take whatever happens. If we, when we talk about natural turf management or organic turf management, sustainable management, it doesn't mean not doing anything. It doesn't mean just stopping what we might have been doing in the past and saying, well, I'm not doing anything, therefore I'm naturally based or I'm being sustainable. But those three words imply a proactive management strategy that we're going to put in place, because when we choose to eliminate synthetics, something needs to go in to take their place, and it's a systems-based approach that does that. We need to choose the appropriate grass species. We'll talk about that all grass is not created equal. Using the best cultivars for the right location. Proper site preparation, critically important to get that done up front. Using appropriate nutrition to meet the needs of the turfgrass system. Using these revised cultural practices and adopting good soil health practices. All of that put together are considerations that we need to have up front, and we address each of these areas individually. When we're now beginning to talk about this turf and grounds management in a non-chemical or a less chemically intensive way, there's two distinctly different ways that we can approach this. We can develop a management program using allowed pesticides, and there are allowed pesticides. We're going to talk in a minute about what they are and how we incorporate that into a program. So just like a conventional program that is set out by the calendar date, we would have the option to then create a program incorporating at certain times of the year some allowed materials. The other approach, and the one that I generally follow, is creating a management plan involving nutrition, cultural practices, and soil health without the inclusion of any pesticides, allowed or not, in that annual program, and trying to build that good, natural, organic foundation to that system. That being said, problems can arise in any horticultural situation, but usually with that organic framework in place or that natural framework in place, problems are easier to deal with. If and when a problem does arise, and believe me, they certainly do, we then can adopt a strategy called a rescue treatment. And we can intervene with a one-time intervention with a certain product. And my next slide will talk about those products for intervention. So because we're talking about these sustainable programs does not mean that we don't have product to fall back on for control. We're just not incorporating it initially into the program. So two different ways, both are legitimate. My preference would be the second.
So we have, I'm just going to share the results, Chip, of our poll.
Sure.
And it looks like 59% have had experience with organic lawns and 41% have not. So there's a good chunk of people that are really new to this. So this is great.
Yeah, it's a nice mix. Yes.
Yeah, exactly. Okay, so everybody should be back to seeing your screen now. We're in good shape.
Okay, so we managing, if we're trying to manage pests, and when we do, if the system is not able to control it, and what we're doing is, and you'll see some slides where the system is controlling it. So we developed same thing in good IPM practices. We've got threshold levels and tolerance levels that we develop for pests. If we exceed those tolerance levels after appropriate monitoring, we have a range of materials that are referred to by the US EPA and been classified by them as 25B minimum risk pesticides. We have horticultural oils and soaps, which are EPA registered pesticides. EPA minimum risk, for those of you that are not familiar with the term, means that the US EPA has chosen to not include them in the registration process because they deem there's no significant risk to human health or the environment. Horticultural oils and soaps, biological organisms for insect and fungal control. Both are generally EPA registered products, but are fully accepted and allowed in our programs. And then the EPA now has a new class called biorational pesticides. Pesticides that, again, are registered materials, but have their origins in natural foundation. Those are the products with which we can intervene. There isn't much there. There's plenty of material there to mitigate any insect pressure and mitigate most fungal problems. The one area in natural management where we're still short is on weed control. We don't have a lot of material available to take care of weeds, so it really becomes a systems-based approach, and you'll see pictures where the system is doing that. This is a list of the EPA 25B product. Many of you may recognize, materials on that list. Cedar oil being used for grubs, pretty potent insecticide in its own right. Citric acid and the acetic acids would be the ones for some of the weed mitigations. Corn gluten meal. Anybody that's ever had any involvement with organic lawn care probably knows about corn gluten meal. If I asked you all, whether you thought it was effective or not, I'm going to get lots of different answers. I personally don't use it because I think it's pretty expensive. It blows my budget, and I don't get the efficacy out of it. The biggest problem with corn gluten meal is if we used it twice a year for 3 years, I'm going to control about 80–85% of unwanted weed seed, but I'm also going to restrict any ability to use grass seed, to overseed if we're in the cool season region of the country or in those warm season regions where we're using a grass that can be reproduced by seed. So this is a list that is fairly extensive and plenty of material on here, as I said, to take care of most all insect pressures, and then we move over to the biorationals to be those fungal control materials. So as we are now beginning to look at this subject, and we have that daunting task in front of us on how we're going to begin to approach this, the site assessment and evaluation is absolutely the critical first step. Gathering the information on the site, looking at the strengths and the weaknesses of the site. Where is our grass doing well? Where is it doing poorly? When we gather that information in that initial site visit, that becomes critically important to how we're going to develop a program after the fact. Soil testing is the basis for all inputs, as I mentioned, in a natural turf program. Critically important. So I think that it's a good idea to take a few minutes here and just talk a little bit about the soil test that we have. I'm sure that many of you that are here today are fully aware of soil testing and all of that it can do, but I also suspect that there are probably many of you that have never done a soil test and not familiar with that. When we are testing, we're either using a soil probe as shown here or simply a trowel. Most of the time I use a trowel because I deal with very compacted situations. When I get called in as a consultant, I'm usually called in because things have gone in the wrong direction and we're trying to sort of right the ship. We're going to go down and take a sample of soil from the 3 to 4 inch range down in the rhizosphere. We're going to take multiple samples for each lawn or playing field, if that's what we're doing. We're going to mix those samples together to form one composite sample. I refer to removing debris, and by that I mean organic debris, blades of grass, portions of the thatch layer, portions of the root zone, trying to remove as much of that as possible from the sample. Because when the laboratory runs a test for organic matter percentage, the test is referred to as LOI, or loss on ignition. They weigh the sample, they burn it, and then they weigh it. And what burns off is the organic, and what remains is the mineral soil. If we're burning off a lot of parts of the grass plant, we could get a distorted reading on the organic matter percentage. I leave my samples out overnight to air dry a little bit. Laboratories generally don't like wet samples. And then I'm going to put basically one dry cup measure into a baggie and ship it to my laboratory of choice. And different regions of the country, all have their own laboratories, some private and some as a function of cooperative extension. First type of soil test, and the most basic, is called a nutrient analysis. It gives us the pH level of the soil. We know that cool season grasses thrive in pHs of 6.5 to 7. Some of the warm season grasses can take it a little bit more acidic and be down around 6 to 6.5. Gives us the organic matter percentage of the soil. Generally 4 to 10% is considered to be the range. 3% the low line to successfully grow things. 5%, 5 to 8%, generally at optimum levels. Gives us a ratio or a relationship between calcium and magnesium. This is basically just turfgrass science, that grass plants like more calcium than magnesium. Those biological organisms that we're going to talk about in a minute also prefer calcium. So we try to balance the soil like that. We look at the 3 macronutrients used mostly by the grass: nitrogen, phosphorus, and potassium. Most grass programs now should be 0 phosphorus, because many regions of the country are adopting fertilizer laws. Grass does not need much phosphorus in order to grow. Fertilizer law tells us that if you have sufficient soil phosphorus, you can't use it to grow grass. You can only use it when establishing a new lawn on bare soil from scratch, or when you have a soil test in hand that indicates a deficiency. I'm highlighting N, P, and K, but certainly not limiting the discussion to those 3 macronutrients. A very flawed concept in conventional agriculture and conventional management, that was developed in the late 19th century, that plants responded dramatically to those 3. So just pump up the crop with, basically nitrogen and some P and K. But an agricultural crop takes 30 nutrients from the soil when it grows, and grass takes 17. So if we continue to just focus on 3, we're shortchanging the whole system. We get information about cation exchange capacity, which is the ability of a soil to hold on to and retain nutrients. So all of this information comes on this soil test. Not very expensive. This is probably about $15 on a national average at most laboratories. The second test that we're looking at is a textural analysis, also called particle size analysis or soil composition. This is where we're going to get specific percentages of sand, silt, and clay, or the mineral portion of the soil, and their relationships to each other. And then that soil will be classified according to the USDA textural triangle as a loam or sandy loam or loamy sand or a silt loam, whatever that happens to be, depending on different regions of the country, and based on that analysis. This kind of information gives us a very strong indication on the ability of the soil to hold water, the bulk density of the soil, the tendency of the soil to become compacted. All of that, this is not something that I would do on individual residential properties, but on sports field management, on condominium, on new construction, where soils brought onto the site are always challenging or can be of inferior quality. It's a good idea if we're involved in an HOA or a new development to do a textural analysis. Can run anywhere from $20 to $50, but gives us that baseline information. And then the third test is a biological assay of the living portion of the soil, a test that actually tells us the biological life that is in that soil in total, and then that portion of that is actively working for us. So we may have a total bacterial or a total fungal population, and then a much smaller number that is active and working. And the results of this test give us those key strategies that if we don't, or give us indication on how we can employ the strategies to sort of wake up some of the biomass and make it work for us. If I didn't have enough bacterial organisms in the soil active, I might have a lot that are dormant, but not a lot active. I'm not going to experience nutrient cycling. I can simply take 1 ounce of blackstrap molasses, mix it in water, and cover 5,000 square feet with that solution and wake up that bacterial life, and then it will begin to work, and my nutrient cycling will be dramatically improved. An expensive test, and again, not a homeowner test, but reserved for some of those larger and more complex projects. Soil test is all about interpretation. Everything that's listed here, there are relationships between all of those, and that's what we're looking at. Not getting necessarily hung up on individual values, but looking at individual things and how they relate to each other. If there are deficiencies, we're going to correct them up front, and then we're going to try to optimize these relationships. Just a quick word about soil testing. If when you do soil test, you certainly want to pick a laboratory and stick with it, because there are different testing protocols employed by different laboratories, and those protocols involve bringing that soil into solution with an acid, and that acid can be either a strong acid or a weak acid extraction. Strong acid extracts a big number, weak acid a much smaller number. Many people feel that smaller number is more similar to what the plant actually has in the soil to draw on. So if you bounce from lab to lab and do a weak acid 1 year and a strong acid next year, you'll experience the situation of the same soil, the same nutrients, but 2 dramatically different numbers. So picking one laboratory and stick to it. Risa, this might be a time to entertain some questions if folks have have questions to this point.
Okay, sure. Yeah. So send your questions in. I mean, I have one. I'm not sure I understand it, but you may. So it's from Mary, and it says biosolids compost showed about 3% phosphorus. How do states view that level of phosphorus?
As excessive. Biosolid material is extremely high in nutrient. I have a slide, coming up that talks about, compost incorporating into a system. A biosolid can be as high as 4% nitrogen and 3% phosphorus, where a leaf and grass compost would be about 0.9% nitrogen and about 0.8% phosphorus. So under 1% is considered to be trace. The US EPA is developing a voluntary program up here in the Northeast, the 6 New England states, New York and included, and they're talking about allowing compost with trace nutrient. If you use a biosolid compost and top dress grass to a depth of 1/4 of an inch at 3% phosphorus, you will end up delivering about 1,200 pounds of phosphorus to the acre, when a soil test recommendation for adequate phosphorus levels would never exceed 120 pounds. So 10 times the phosphorus can be delivered with a biosolid.
Huh. Okay. Someone asked if you could repeat the molasses remedy.
Molasses, 1 ounce of molasses incorporated into water, delivering that solution between 2 and 3 gallons of solution to 1,000 square feet. and that 1 ounce will cover, so 10 to 15 gallons of water with an ounce of molasses in it will cover 5,000 square feet.
Okay. And then one question, this was earlier on about when you were talking about your chemicals and pesticides. And it's Benoit he's near Montreal. Benoit, I grew up in Montreal, so welcome. He wants to know about biochar. Is biochar considered, it's not considered a pesticide, I know that, right?
No, biochar would be considered to be a soil amendment. So it's working in the soil. It's a relatively controversial subject because of the energy that's used, into it. So the use of energy that it takes to produce the biochar.
Yeah.
So within the industry, people line up on both sides of it, but would not be considered to be a pesticide, but soil amendment.
Okay. And then a question from Hillary is just to explain biosolid compost, what that is.
Simply put, biosolid is sewerage sludge. So in the wastewater treatment process, the solids are filtered out of wastewater, and then the water is then purified and then discharged, and the solids remain. The solids go through a process involved with the introduction of bacteria or the decomposers, and it actually, the biosolids are, or the solid material is then comes out as a compost. The downside of it is if it's in a part of the, if it's in a region where there's a lot of industry, heavy metals end up being in there because they bind themselves to the solid particles. And I think for many of us, the more concerning factor with biosolids is the fact of medical waste, of pharmaceuticals,
Oh, right.
anything from birth control to antibiotics to growth hormones and chemotherapy drugs, all adhere to the solid particles and then can end up being introduced into the landscape.
Oh, right, right. So the other question here is, okay, if you send a soil out for a bioassay, does the biology remain unchanged in transit? Or in an anaerobic container, does it change the makeup of soil biology from in the soil? I guess it's the question is when you're sending things out and it's,
Mm-hmm.
closed, what happens? Does the
Yeah,
biology change?
no. What you do is it's critically important, and and again, certain little details in these short time frames, get overlooked. But overnight, it goes FedEx or UPS overnight. So what I do is, as I mentioned, it's 1 cup of soil to do a nutrient test or a textural test. If I'm doing a bioassay, I'm going to use 2 cups of soil. I am going to keep some of the plant parts in there because the biology is involved in the whole plant and the whole system. And I'm going to put my 2 cups into a 1 gallon trash bag, 1 gallon, not trash bag, 1 gallon baggie. And then I'm going to seal it so that I have included air in there. If it gets to the lab within 24 hours, it doesn't have time to go anaerobic, and it gets there in good, viable testing form.
Okay, great. Okay, Chip, I think we're good.
Well, good. Okay, so soil biology, just a little bit of an overview. We could spend a whole day, talking about this aspect. But, my summary is that a healthy soil will retain nutrients. It promotes nutrient cycling. That is nitrogen being cycled to the grass plant. A healthy soil can cycle up to 2.5 pounds of nitrogen every 30 days into the roots of a grass plant. It will break down pesticides, environmental toxins. It helps to build, or in the case of a deprived soil, rebuild soil structure. Beneficial organisms increase, and that increase leads to the reduction of root and foliar pathogens. It allows us to reduce water use over time, increases water holding capacity, and then improves rooting depth. So the biological complex in the soil is responsible for all of that. A conventional view of soil, and not my slide. This was given to me by Penn State. Looking at the 3 aspects of soil: structure, meaning chemistry, structure, meaning texture, sand, silt, and clay, the chemistry, that's soil nutrient, and then the biology as 3 separate independent areas of soil that have a long time been thought to be not related to each other, but as standalone aspects of the soil. Penn State, through their ag, their ag program, 7 or 8 years ago, began to look at the interrelationship. So what they call an emerging view of soil health, where these are definitely related to each other, and that intersection in the middle is referred to as that healthy soil or quality soil, and the humic properties of the soil, humus as that long-term energy resource, that end product of decomposition that's fully stable. Humus is critical in facilitating this interaction. So this is now more the emerging concept that we're beginning to look at. As we begin to understand the role of the biomass, we begin to move towards that position of experienced success with management of athletic fields, grounds, lawns, without the use of traditional chemical pesticides. There's certain fungal organisms that get encouraged and can be introduced, or we grow them naturally, that will outcompete many of the fungal pathogens. So we're now looking at the biology, looking at the biomass as our partner in helping to create situations that are going to reduce our dependence upon many of these products. The end result of the healthy biomass ultimately means healthy, more vigorous plants that can withstand pest pressures, and we're going to see a picture of that. More beneficial microbes to compete with potential pests. Not saying that, say, an insect can't lay an egg in a healthy, biologically active soil and some potential problem develop, but when many of these insects lay their eggs, they're pretty close to being microscopic, and they end up to be just simply a food source for some of the more, the higher level predators that are in the soil. So we begin to get this natural control. We see fewer weeds, and that's exactly what happens once we reduce the chemical process and begin to work with this biology. We have certain organisms that colonize the roots of our grass plants, that don't colonize the weeds and give the grass plant the resources to begin to outcompete the weeds. The reduced need for water and improved soil structure. When we pick up a handful of soil, only half of it is solid, mineral and organic matter. The other half is air, and then part of that airspace is filled with some moisture. So in this soil now, we're beginning to think about this concept of feeding the soil and not the plant. Synthetic fertilizers directly feed the plant. We'll talk about that in a minute. But now with our organic products, we're first feeding the soil and the microbes, and they in turn are addressing the needs of the plant. Many different organisms down there, all existing in the healthy soil, including those four different species. These organisms unlock nutrients in the soil so that plants can take them up as food. So now when this nitrogen down there gets unlocked from our organic fertilizer, it's in a non-leachable form because it is now within the body of these organisms. So it cannot move off the site. So we're now beginning to create systems where nutrients are held in place. In a nutshell, what happens is microbes are feeding on each other. They're feeding on organic matter, they're feeding on our organic inputs, and on exudates from the plants, that root system that's a two-way process. Nutrient and water goes up, but exudates, particularly with grass, it's the carbohydrates that are produced in photosynthesis, end up feeding organisms that are colonizing the root system. So one organism consumes another, a protozoa, a higher level predator, will consume a bacteria. The end result of that process is the release of nitrogen in a plant available form. In a healthy soil, as I mentioned, we can get that 2.5 pounds of nitrogen cycled on a monthly basis. They're helping to build soil structure, holding soil in place. Soil structure is a concept that means that all soil particles, from the most microscopic sheets of clay up through the silts, which are the next finest particle, and then those large grains of sand, all soil particles should be surrounded on all sides by air. Air contains oxygen. It creates an aerobic system, and the biomass is happy, and the roots of the turfgrass that are entirely dependent upon oxygen become happy as well. Poor, compacted, or anaerobic soils reduce microbial populations. The lack of organic material, that organic matter percentage, think of that percentage, that small percentage, as the home for the microbes. Repeated chemical treatments reduce some of these, particularly insecticides and fungicides. Herbicides aren't terribly harsh on the biomass. We have concerns about them for other things, but it's really the insecticides and the fungicides that are a little difficult on the biomass. Typical non-forest soil profile in most regions of the country, where 45% of the soil is mineral, sand, silt, and clay, 5% on average is organic matter, and then in a soil that exhibits proper moisture, not to excess, we have 25% air and 25% water. So what this pie chart tells us is that that handful of soil, half solid, half air, and what our critical job then becomes is to keep that soil so that air is always in there. It's all that pore space. Pore space is that air pocket that surrounds the soil particles, and always keep that oxygen available to the system. Fred Magdoff, professor at the University of Vermont, well known in this field, talked about organic matter as decomposition for energy, or the residue of life, breaking it down into three fractions: living, dead, and very dead. Living would be roots, earthworms, insects, the microorganisms themselves. The dead fraction would be that active organic matter, that 4.2% organic matter. Recently deceased organisms through that natural predatory process. Fresh plant residues like the recycling of a grass clipping or the top dressing with a compost. The very dead fraction would be humus, that end product of decomposition that can break down no further. All of this together then becomes incorporated into the description of what organic matter is. Two considerations: the effect of organic matter itself. It helps build soil structure. It helps hold soil structure. Chelation of micro and macronutrients, meaning chelation to make soluble. Grass or any plant in the landscape can only use nutrients when they are in a soluble form. So the organic acids from organic matter solubilize insoluble nutrients. A pH buffering capacity. Bacterial organisms are pH neutral. So when we get the right percentage of bacteria there, the soils become buffered to be sort of in that range that we desire. As organic residues decompose, we get better aggregation, nutrients are released, biological activity increases, and then one of the end benefits to us is disease suppression. We have things happening for the long term. Biological activity increasing permanently. Moving that organic matter from 4 to 4.5 or 4.5 to 5%, increasing that persistent aggregation, that soil tilth, that health of the soil, improving water holding capacity, water infiltration, and helping to hold that pore space and making aeration becoming more effective. And then we get incidental and side benefits in the improving cation exchange capacity, that pH buffering capacity, and an ongoing nutrient availability. In the short term, all of this is happening for us right from day one. And that is, we acknowledge that and we understand that in the program and we take advantage of that. But ultimately, the goal is to achieve those longer term effects. Gives us this poll question, incorporates this last few minutes of the discussion. And now we're going to, go to the idea that we've talked a little bit about that soil. We've talked about the soil testing. We are beginning to understand the importance that that healthy soils play in all of this. And now we're going to bring in the concept of the grass plant itself. And we're going to talk just very briefly about the genetics of grass, because as I mentioned, all grass is not created equal. Again, a couple of slides that is going to give you this overview of this situation, but what we're looking at, and this is probably most important for those of you that are in the, the architect, or the design stage of things, because just putting in in a design, a grass system without making the recommendations for the right kind of grass system may not give the person doing the installation the right, the right information or the right strategy.
Okay, so I'll stop you there too. I'm going to share the results. So actually, 58% of our group has relied on some of those strategies, the soil testing and the looking at that. But a good chunk, 42% have not. So this is good for the good education.
Yeah, and 58% is great. That's actually a higher, and I suspect it's because of the group that we have here, but that's a higher percentage than I normally find.
Wow,
Normally when I'm dealing with an audience, the number's around 30-35%. So that's fantastic.
wow.
Um, at the design stage, understanding grass is important to its success. We have to get the right grass species for the right location. The wrong grass in the wrong location leads to a dependence upon synthetic use for both fertility and control. Number of reasons for that, but all grass isn't strong enough to take certain wear and tear, and then other grasses, they can take wear and tear, may be higher maintenance, and they may need more input, and we might not want a high input landscape. So if we're trying to do a high input landscape, we're not going to allow grass to be planted there that's a high input grass, because it will fail and it will not meet our expectations. Whether we're dealing with cool season or warm season grasses, there is always the right plant for the right place. So within both the sets of grasses for the different regions of the country, we have all the genetics that we need to choose from to put the right grass in the right spot. And again, getting that information up front and getting things right from the beginning is critically important. And that being said, it's my strong belief that grass is not always the appropriate plant. More often than not, I get called in when someone has tried to force grass where it does not belong. And then there are problems. So those turf grass alternatives, those other very valuable plants, preferably within each of your regions of the country, those plants that are native, may be far more appropriate than trying to force grass in there. So, that is a very important concept to understand. Paying close attention to the soil and the right grass plant determines the difference many times between success and failure in the landscape. Much easier, as I said, to get it right in the beginning rather than to try to correct problems after the fact. Many grass systems, both residential and sports turf, fail or have big problems because of inadequate strategies up front that we have not really addressed up front and put the right grass in the right spot. Bottom line is it just better allows us to meet client expectations. And that's really where our job fundamentally begins, is we need to determine what those expectations are and then put the appropriate plant there to allow us to meet it. The right grass determines the level of inputs. We may have a low level input system, a high level input. Bottom line is all the inputs should be reduced from this point forward. The concept that less is more really has to be the buzzword to guide us in how we're putting materials into the landscape, synthetic or organic. Choosing the right grass most oftentimes reduces the need for control inputs. So if we, in the cool season region, we all know that there is shady grass seed as an example, and that shady seed is fine fescue. But if we put that fine fescue in an intensively used landscape, it will fail because it's too weak and it can't take that. And then that leads to a synthetic control product to try to get it back on track. So just an example of the wrong situation there. A little bit about turfgrass nutrition, critically important to the process. Less is more, the most important concept. I mentioned the national regulations that are appearing, or not national, but are happening. I think 13, 14, 15 states now have restrictions on what can happen to fertilizer. No phosphorus, restrictions on nitrogen use, restrictions on timing of the applications. These are our basic fertilizer nutrients: nitrate, nitrogen, NO3 minus, the soluble nitrogen, NH4 plus, ammonium, that nitrogen that is not soluble but strongly attracted to those cation exchange sites. We look at this as reserve nitrogen. And then we have potassium and then phosphorus as we understand it in the phosphate form. Grass gets nutrients it needs from minerals in the soil, organic matter, fertilizer, and to a lesser extent, the atmosphere. And what I mean by that is if we have clover in a turfgrass system, clover is fixing nitrogen from the atmosphere and translocating it and making it available to the grass plant in a plant available form. Grass gets, one of the reasons that we use fertilizer for grass is because nature cannot provide enough nitrogen on its own if we are trying to manage to those higher levels of expectations. If we have lower levels of expectations, many times our grass plants can get by just on what is being made available through nature, and we don't have to intervene. But if we are trying to manage to those higher levels, we need to do something. Very important concept. There is no plant food whatsoever in a bag of fertilizer. So that nitrogen, phosphorus, and potassium are not plant foods. They are simply raw materials that are involved in many plant processes, but particularly photosynthesis. So a grass plant's response to nitrogen can be several: top growth, root growth, horizontal extension, or spreading itself out to thicken. Another response is getting greener. The green is chlorophyll. So nitrogen intensifies chlorophyll. It's a raw material that increases chlorophyll density. That chlorophyll then reacts with energy from the sun in the presence of carbon dioxide and moisture. Stomates, microscopic openings on the underside of the grass blades, open and close at dawn and dusk, and the CO2 goes right in there, reacts with the chlorophyll, and produces carbohydrates and sugars. And that is plant food. And that's what the plant grows on day to day. It stores it within its crown for periods of low carbohydrate production, and then the balance of it is exuded through the root system. Again, grass can be grown without N, but we don't get that high quality. What happens is we have the natural process of mineralization. So mineralization is that that concept that is fundamental to how organic fertilizers work. So we have a synthetic fertilizer that is water soluble, and we put it in and it works very quickly. It begins to work fast. Organic fertilizers are different. They work a little more slowly. So we open up that bag of organic fertilizer and put it on the grass. Bacterial organisms interact with that. They break it down. They convert the organic nitrogen to inorganic because the grass plant can't use it in the organic form. So what happens is the bacteria convert it to nitrogen, and that is held in the soil. Nitrifying bacteria move in, and then they convert some of it to nitrate. Grass prefers 50% nitrate, 50% ammonium, and now the system is allowing that and making the conversion to inorganic, those two forms, and the grass gets the nutrients that it needs. We need organic matter, humic additions, and or fertilizer applications to supplement the natural supply of nitrogen when we are looking to manage to those expectations. Traditionally, in conventional terms, the benefit or the benefits of fertilizer or how well they work were measured by growth rate and color. They'd make an application of fertilizer and then a week later cut the grass, bag the clippings, weigh the clippings, look how much poundage was produced, and do that at 14 days and 21 days and 28 days, and they could determine how much growth they got from that application. Really not the most important criteria for determining quality. Many turf agronomists now will come right out and say color is not important. Extensions, I was at an extension lecture this summer, and the head turf scientist said color is not important. It's grass is green, but not the driving factor. Far more important to us to measure the effects of nitrogen are root growth, carbohydrate reserve, shoot density, how well does it thicken, stress tolerance. How well does it stand up to adverse conditions? So this is really sort of the concept that we're looking at. Natural-based fertilizer, nitrogen, this is actually a misprint and I apologize. It should say nutrient is from plant, animal, or mineral sources, nitrogen from plant or animal source. So from protein, nitrogen is a building block of amino acids and proteins. In organic fertilizers, the nitrogen is water insoluble. It does not break down with moisture, but it is broken down by the biomass. Slow release, microbial action, long benefit, sustained benefit, very measured growth, and extremely cost effective. Nitrogen from the conventional side of things, those conventional fertilizers, nitrogen is primarily from urea, synthetic, inorganic. It's water soluble. There are strategies that they can employ to encapsulate that prill with either sulfur or a polymer coating, or secondarily react that nitrogen with formaldehyde to come up with a material that is insoluble, that actually does take microbes to break it down. But for the generally speaking, with those soluble forms of nitrogen, it's in quick and it's out quick. And that's why we need multiple applications throughout the growing season. A little bit of just a side note that in the production of this type of urea fertilizer, it takes 5 tons of petrochemical equivalent input to make 1 ton of this fertilizer. So not really a very sustainable approach, that much petroleum and natural gas, being used to produce this. Following a soluble application of nitrogen to turf, growth rate increases sharply 48 hours after application. Peak growth or maximum release of the nitrogen is 7 to 10 days after application, and it tapers off to the original growth rate in 4 to 6 weeks, meaning the nitrogen is all gone. So this is a peak and a valley of fertilization, not necessarily a very desirable situation. Can have a detrimental effect on the grass. These short bursts of growth after applications, followed by periods of slow growth, are a prime cause for the depletion of carbohydrate reserves, a reduction in root development. In other words, it's a stressful situation that eventually can thin out a turf system. So, a kind of a stressful way to fertilize. Mineralization absolutely is the science behind organic fertilizer use. We have to understand the concept, as I mentioned, that plants can only use nitrogen in the inorganic form. That's why we went to a laboratory to develop it. That's why the synthetic fertilizers with their highly water soluble, high salt levels work so fast. And that's why now we focus on building this microbial community and allowing that community to make that conversion from an organic form of nitrogen into the inorganic. The key to successful fertility is to deliver just enough nitrogen in the early part of the growing season to get optimum shoot growth without excess at the expense of root growth, and to deliver enough nitrogen later on in the season to address the aggressive root growth. That is sort of the recipe for cool season turf. Warm season turf, very similar, but we're just targeting the nitrogen at a little bit different times of the season, again, coinciding with the natural growth pattern of the grass. Just a little bit on compost. That question came up. Microbial life in compost is the key to a healthy turf system. It's a great source of organic matter, beneficial microorganisms, a major energy source for plant life, millions of beneficials. It's nurturing the development of the soil system. So there is a substantial nutrient release from compost, as I mentioned with that phosphorus discussion on biosolids, but we're looking at it as a soil conditioner and acknowledging that we are getting nutrient benefit. No national criteria, standards, or guidelines, so it becomes up to us to make our own judgment. So we need to rely on soil testing to determine maturity. But as a lay person and without testing, a handful of compost should have no offensive odor, shouldn't smell like ammonia, turpentine, bark mulch, no remnants of initial feedstocks, that should look, smell, and feel like a high quality soil, and absolutely has to be mature. When we are top dressing turf, we are looking at just putting down about a quarter of an inch of the material, and then letting that very little bit do its work for us. Risa, if you wanted to entertain a few questions at this point before we move into the final section, it might be a good time.
Okay, sure. There's quite a few, so as we thought. So one question is, what's some of the best ways to create pore space in silt clay soils?
Silt clay soils are those finely textured soils, silt being very flowery feeling and clay being very sticky. It is improving or working within that organic matter fraction. If the soil is compacted, in other words, we should be able to take that coring tool or a trowel and relatively easily, with a firm, steady pressure, be able to insert the coring tool or the trowel to a depth of 4 to 6 inches. If we can't do that, then the soil is sufficient bulk density and probably exhibits some compaction. So aeration to introduce oxygen and pore space is the first step. I'm going to show you a sample of soil in a few minutes that I can penetrate 6, 7, 8 inches down with very little pressure. And that was not done with aeration, but it was done with biological. The biological organisms are very powerful in helping to relieve compacted soils.
Okay, so there's so many. Let's see, I'm just looking. How many aeration? Well, aeration, you're going to talk about it. How many aeration sessions are needed to open up highly compacted soil? But I guess you'll talk about that, right?
Yeah, I can do it right now. I mean, if it's residential turf, twice a year in the first year. If it's sports turf or heavily used turf, you're looking at like sports turf. The recipe is 3 to 5 times a year.
Yeah. Okay. Okay. Now, there's a question about creeping Charlie, which is a weed, but is that like a whole separate issue, right? Weeds, managing weeds.
Yeah, and that's one of the things that we're, not, because again, the time, here is not sufficient to go into all of the weed management. Creeping Charlie or gill over the ground or ground ivy goes by many different names. Difficult to manage. A little trick. I've actually knocked it back with, believe it or not, 20 mule team borax. Again, boron can be an applicator issue. An overdose of boron, can be bad for the soil, but a modest 20 mule team borax spray, I probably got a 50% knockback on creeping Charlie.
Hmm. Okay, another question is, what about thatch as an element of the soil tester site survey?
You mean about thatch? Well, thatch you want to identify in that site analysis. That's one of the things we look at. A one half inch of thatch is a desirable situation. Once thatch begins to approach 1 inch or more, it needs to be managed because it severely restricts the development of the system and of the grass plant. So if we're doing the soil sample, we're taking that thatch layer out of the soil sample. But if that thatch layer is present, then a good way to determine, what is there is a finger test. Simply take your fingers, go right down and probe right down through the blades of grass. And if you can relatively easily touch bare soil, you don't have a thatch situation. If you can't, and you have to sort of scrape and probe to dig through this thatch layer, you need to be managing it. It can be managed with the power rake or vertimower and mechanically pull it out of there. A core aeration will help to manage thatch. Or then we can do it passively with a compost top dress, a compost tea, or the introduction of specific saprophytic organisms that are the decomposers that will biologically take the thatch out.
Okay, there's quite a few other questions, but I think those were the most pertinent to the whole crowd.
Okay.
So I'll let you keep going.
And if anybody, my contact information, certainly anybody has questions when this is done, please feel free to email me and I will be more than happy to follow up with any of you. The cultural practices, again, because of time constraints, one slide here. Many of you know about these and do these regularly. Not enough time to go into them in detail, but we're generally looking at higher mowing heights than we might have been doing in the past. Turfgrass science tells us that for many grasses, 3 inches is the stress-free height. So where, it allows the system to develop itself. So we're developing mowing practices that complement this organic or natural sustainable approach to management and product choice. I can tell you that if you can put the best natural program, a sustainable program in place, but if you have very poor mowing practices and continue to scalp and cut short, you're going to have problems. So, mowing is one of those cultural practices that's important. Proper irrigation. More problems in grass happen from over watering than for under watering. So managing irrigation, the bottom line is deep, thorough irrigation is more preferable than repeated shallow irrigations, unless we're in the middle of a deep, hot, prolonged summer. And then we might choose to irrigate, frequently and shallow in a process called syringing to cool down the system. Aeration, we talked a little bit about that. Mechanical aeration, simply pulling a core. To give you an idea, the benefits of aeration last only 3 to 5 weeks. So it's not a permanent thing. So in some of those tight soils, it's an ongoing issue. But again, in a minute or two, you're going to see some pictures where that level of aeration happened through the biomass. The biomass works its way down and loosens soil as it goes. The dethatching, I addressed that issue. And then seeding and overseeding. Certainly overseeding is something that is done in cool season turf. Not all warm season turf can be improved or thickened through overseeding. Some of it is only through sodding or sprigging. So we're looking to develop and thicken what is there, as opposed to using additional seed. So again, the genetics of individual species determine which ones can be seeded or overseeded. And in those ones that we can, this is our primary method of weed control, just improving turf density and trying to get it at its maximum level. So again, just a very quick overview of the cultural practices. Again, if any of you have specific questions, please feel free to email me and I can elaborate on one of those areas. So now we're getting, towards the nuts and bolts and sort of coming towards the end of trying to tie some of this together. Bottom line, in any type of a program, conventional or alternative programs, low level of input equals a low cost, and that yields low expectations. Higher level of inputs equals a higher cost, and that's what yields the higher expectations. So certainly something that is true. What you're looking at here, good shot of an all-natural sports field. That gets extremely heavy wear and tear and can actually stand up to that. But this is how we develop programs. So we have programs that address the lower level and programs that address the higher level. Absolutely important that we all understand and agree that low quality is not necessarily bad and high quality is not necessarily good. It's the right quality, the right expectation for the right location. And that really is what it's all about. We're certainly not interested in imposing high quality standards in those situations where, where we shouldn't be seeing them. Cultural intensity is the amount of fertilizer, water, aeration, overseeding, that needs to be done on an annual basis. It relates directly to the amount of inputs and time required to keep lawns and turf in a condition to satisfy expectations. So whether we're a landscape service provider, whether we're in a school district or a municipality, critically important during that site analysis and those initial discussions that we determine the expectations from end users or a client on any individual situation. I'm going to, go through, the last and show you a case study. This is a project that I'm working on, a 1,000 square foot sort of a formal case study that I've been undergoing. And Risa, maybe while I'm doing this, you could launch that third poll, and then and then we can get that. And when I'm done, we could take some last questions if they come in.
Okay, so this is about the education, right?
Correct.
Yeah, the polls, given the opportunity to get proper education, would you consider adopting organic, sustainable practices and products into your landscape? I'm so sorry, I don't know why it got cut off here, but it did. It got cut off, but it didn't when I entered it. So just have everybody vote. And
then maybe a secondary question, if they wanted to answer a second question on this one, is that do you think or perceive that there is a market opportunity, within your individual region? And certainly we know that some regions of the country are more forward in this process of natural, alternative strategies. So, while you folks are doing that, this is a case study that I have conducted myself as a field trial. And this area is measured out to be exactly 1,000 square feet. It began in July of 2012. It's ongoing. You're going to see photographs from 2012 to, right to the day before yesterday. What we have here is what we had initially. So you can see bare spots, weed pressures, significant weed pressures. Sort of the weed grids initially showed that in parts of this, we were, the overall average of weed pressure in this was about 65 or 70%. This is a Kentucky bluegrass sod that was put down 30 years ago, totally neglected. Little or no fertilizer, little or no water, and it had just been basically mown and maintained. And weed pressures had come in to be that significant level. A whole series of cool season broadleaf weeds, as well as significant crabgrass pressure and substantial clover pressure. Over on the top left-hand corner, you can see the mowing heights that we were looking at. The grass in the background there is up to 4 inches, and then in front of that is a mowing height at 3 inches, and then in front of that is a mowing height at 2 inches. So that's what the different mowing heights look like, and different strategies at different times of the year. The picture in the upper right and the lower left shows what can happen with compost. This is municipal compost, and look at the weed pressure that grew from that compost. So, compost has to be properly made and properly managed in order to compromise weed pressure and to mitigate it. And it can be mitigated as long as the core temperature of that pile gets warm enough. And in this case, it didn't. So all of that weed pressure grew out of that. And bottom left, look up against the fence there. That is just, they were very, very small weeds that were growing against that fence line. And look how big and healthy and happy they are. That is the nutrient runoff from the compost. So that is the nitrogen running from that compost. 60% of the nitrogen that is available in a compost pile is readily available, and 40% is available over the longer term. So that is that readily available nitrogen. So you have to be careful with compost. You really do need to make sure, again, compost like grass is not all created equal. Bottom right is a picture of a cool season grass, because I'm in the cool season region, and that's Kentucky bluegrass. And you can look at all of those reproductive structures down in when you look at the root, on the right side of the root of that grass plant, that is a Kentucky bluegrass rhizome. That's how it reproduces. All of those structures reproduced from one crown, from one mother plant. And so that's what we're doing. And that reproduction is a direct response to applied nitrogen. And that's what we're working to do. We're working to make that happen with whatever the individual species is, and whether the grass is rhizomatous, stoloniferous, or a tillering grass. using nitrogen and not really caring about what grows on the top as far as blade length, but looking at that horizontal extension. How can we use that nitrogen to make that happen? And again, that nitrogen, the concept that less is more. The final pictures that you're going to see here of the end product of last week involve 1.5 pounds of applied nitrogen since last April. So minimal nitrogen, way below what most turf programs would call for. This shows some of the clover that's in there. And that knockdown of the clover was done with an organic product and an almost organic product. Some of you have probably heard of a product called Fiesta, which is a chelated iron. It's a natural iron that is involved with synthetic intervention, but it has herbicidal properties. And that material was combined with a salt-based product that's called Adios. And it got that kind of knockdown, but you notice it's not eradication. Important to understand that herbicides suppress, they do not eradicate. You can see at the bottom left on a crabgrass plant, not particularly effective on crabgrass, but that's the reaction. Bottom right shows a blighting of the lawn. I purposely made that application on a hot summer day, and that's the kind of an impact that can happen. So just because a product is natural or organic in nature doesn't mean you throw caution to the wind. There can be some degree of harm from all the natural products. And I did this on purpose. It wasn't, I did this on purpose because I wanted this picture so I could show that, yeah, this is sort of an alternative herbicide, but you have to be careful. Drought. This lawn this year went into full dormant drought, or almost dormancy, to the point that I was ready to give up on it and just cut it out and do sod, because I had run my experiments early in the season. And I chopped it down to 1.5 inches. I withheld water in 90 to 100 degree weather, and it wouldn't die. It just didn't want to give up the ghost. I decided that it was a survivor, and I would continue the trial. You're also looking at, up in the upper right, some drought, some grub pressure. Bottom left, there's grub damage. So then we opened up a square foot, cut a 12 by 12 by 12, and pulled it back. And you can see that I'm dealing with 6 and 7 grubs per square foot. The threshold level is 10 or 12. So I decided I did not want to treat. I wanted to leave those grubs there and show that I could stimulate that system and tolerate that insect pressure without experiencing turf damage. And that's the end result as of 2 weeks ago, actually 2 days ago. That's what we've got. We've got a system that is weed pressure at 3%. So between July of 2012 and 2 days ago, we reduced weed pressure, significantly. Not much of it was reduced by that, the Adios and the Fiesta application. It was reduced by the system. We're seeing in the top left a weed that came from the compost. So that was introduced with the compost. Upper right, dandelions beginning to be crowded out and choked out by this aggressive turf system. Bottom left, a sample of the soil. And on the bottom right, if you look closely, right in the middle of that soil, you can see that root coming out of there. That is 8 inches below the thatch layer. So we've got that kind of a deep root system, this is a sandy loam, not that heavy clay or silty loam, but a sandy loam where there was no aeration, and all of that penetration happened through the biomass. In other words, it loosened that soil, which was compacted to begin with, and it all happened biologically. And that's where we are as of today. Upper right, that's the long shot, and then the others are close-ups. And as you can see, we've developed a system here that we have suppressed the weeds. We have created this healthy, vigorously growing system. In the top left picture, over to the left side, is where those 7 grubs were discovered. And they're not causing any problem. So the aggressive help of the system has been able to suppress and control. and that is it as of the day before yesterday. So that is the 1,000 square feet that we've taken from that initial picture and sort of turned it into that. Risa, do you want to give us the results of the poll before I do my last final thoughts?
Yeah, well, Chip, 100% of people would definitely switch, and there seems to be a lot of demand for, in all different areas of the country for this. So some just starting and some have huge demand. So I guess there's a whole spectrum depending on where you are.
That's fantastic. That's sort of great to hear. And one of my strong focuses is now to really bring some of this very technical and scientific education into regions of the country where it may not have been available in the past because as you can see, and what I've done here with this picture that you're seeing is low cost, no more expensive than a conventional program. It's a low labor, low input. The basic premise of this trial was to come up with something that would meet my expectations, would give me the results, would be cost affordable, and easy for somebody to put into practice and make money at it. So in wrapping up my final thoughts, I certainly are looking to get across the message that the sustainable lawn care is doable. It no longer is it as cost prohibitive as it once was because we're not relying just on those expensive bags of organic fertilizer, but bringing in other forms of nitrogen using humic acids and kelps and molasses, minerals. I'm using minerals reconstituted or from seawater where we take out seawater. There's materials out there, and the water is evaporated, the salt is knocked out, and 65 minerals remain. So the remineralization concepts, everything that we're putting together is low dose. If we have the ability to deliver liquid, we can put a combination of low dose materials into a spray tank and make an application that is about the same cost as the conventional side. We need to understand plant genetics, make that a strong focus. We're not looking at, I think you can see now that we're not looking at just a program of opening bags and making applications, but we're really trying to, not just be a manager of grass, but be a grower of grass. And coming from the greenhouse industry, I'm a grower of plants by trade. So I look at grass as a horticultural system that I'm trying to grow. We need to adopt good horticultural practices, approaching it as that overarching, the blending of grass within the whole landscape, growing that whole landscape, trying to get it right from the beginning if we're involved in a new construction, if we're in the design and build side of the industry, beginning to understand this system and how grass fits into the system and the right grass for the right situation. If we're in the management side, we're going to begin to learn to create and maintain the system and let that system work for us. And certainly, the concept that, we can experience success. Most of the school districts and municipalities that I work with around the country that are in conventional programs have weed tolerance threshold levels of 5%, even with chemicals. We can easily match that if we begin to approach this, natural or alternative sustainable programs, from sort of the ground up and begin to look at it as a whole system. So that is the end of my formal part of the presentation, and it's up to you, Risa, if you want to take a few more questions or where you want to go from here.
Well, we're running late, but I mean, there's still people on and
Yeah.
they're staying on. So if you want to take, we could take a few more questions that seem pretty relevant. So let me just scroll through them. One is, do you recommend core aeration prior to compost application?
Yes, anytime I do a compost application, I would always prefer to core aerate and then do the top dress application and allow some of that material to enter right down into the core and move into the root zone.
Okay. Then there's a question about how often do you compost You put your quarter-inch compost on.
That's the kind of a thing that is usually done in the early part of a program, like in the transition couple of years. Not something that needs to happen on an annual basis after that. So I generally would try to do it once a year for 2 years, and then that's one of the expenses that should be able to fall off.
Okay, so those seem to be some of the bigger, I think that not more specific. If you guys have some people, I didn't take your questions because they were very specific, but do you have your email address on here? If you go to Osborne Organics, right, we
Yeah,
should
my
get it.
email, and it's not, I left it. I don't know why. I should have been on here. I guess it's below the footer. It's co@osborneorganics.com.
Okay. And it's probably on your website, and there's a phone number for you.
It's on
So,
the website, and we have a new website, and then a whole. I'm actually developing a brand new website that will be up and running in about 4 weeks. That we're really trying to build to be a strong resource for the sustainable industry.
okay. Well, thank you so much, Chip. I know we ran over, but I think, I got a lot of comments that people were trying to write down exactly what you were saying. So, I mean, every word was very important. So I just want to thank you so much for joining us. And I want to let everybody know that there's a lot of questions about this presentation. We are recording it. There didn't seem to be any technical issues. So assuming that all the files get compressed properly, they will be put up. They'll be archived, and you can go to our website and look for webinars and archived webinars, and they should be there. So that usually we get those up within a week or two of the webinar. I want to just thank everybody again, and also mention that you'll be getting an email after this, and there's a survey, and so we really would love your feedback and your opinions and input into this whole program. It's really important. So thank you everybody so much, and again, thank you, Chip, for joining us. It was so educational. And
And thank you. I certainly appreciate the opportunity to chat with everybody tonight about a topic that really deserves a measure of importance. So thank you very much. Appreciate it.
okay, good. Well, thank you, and good evening, everyone. Okay, good. Well, thank you, and good evening, everybody.